Hi guys. So I've been studying systems design for a while now, and I think as a data scientist or AI engineers, I don't think we see it enough. I think it's an important topic. I see it often in job interviews, and as data scientists or AI engineers, we often focus a lot on algorithms and things like that, and less on how AI interacts with the whole system. So I thought of making this tutorial, which is partly focused on how to deal with these interviews from the point of view of an AI engineer or data scientist, but it can also be very helpful for you on your job to understand how your AI model will interact with the rest of the system. So for the interview, I'm following a sort of script that I got from this book called System Design Interview. It's a great book for either software engineers or AI engineers that want to get into systems design. And I think most of the tutorials we see out there, they focus a lot on software engineering. And as a data scientist or AI engineer, you can sometimes get lost in all of that. So I decided to make a version of that in the shape of a tutorial, focusing mostly on what matters for us. So what this book suggests for interviews is that you use a sort of a script which has 4 steps. First one is clarifying questions. So this is where we'll ask all of the questions that we need in terms of requirements, numbers, things like that, that will allow us to move on to the next steps. So the next step is to build a sort of a high-level design. And the third step is to deep dive. And finally, you wrap up. So on the high-level design, you just get an overall view of your system. On the deep dive, you focus on some of the key components. And in the wrap-up, you try to find some flaws in your system, some bottlenecks, things like that, that could be improved. So these will be our script moving on. Now, for this tutorial, I will tackle a problem which I've seen before, and it focuses on AI, but in the sense of a broader system. So we'll be simulating what we would do in an interview. So the problem would be design a system that harmonizes CSV files. So multiple users come in, upload their files. All of them are CSV files, and then you have this sort of standard template or standard schema for CSV files. And whenever these files inserted by the users do not match that specific schema, we need something that will adapt that. So change column names, change maybe data types, things like that. Once the CSV are harmonized, we can then store them. That's the task. Let's start addressing the first step. Now, the first step is clarifying questions step. I like to tackle these with what is the minimal output. So for me, the minimal output they should get from clarifying questions is this. First, functional requirements. Then non-functional requirements. And finally, some key numbers. Now, if you're not familiar with these, so functional requirements are the things that your system should do. So in our case, it would be something like, uploading CSV files, converting them, processing them, whatever, and then storing them. So things like that. These are the functional requirements. For an interview, this is usually enough, but it's better to always clarify with the interviewer. And for real-life systems, you would also have things like user authentication, security, things like that. Non-functional requirements, they can be translated into many different things like scalability, reliability, latency, things like that. I like to keep things very pragmatic. I think it helps me. So in terms of non-functional requirements, I always look into consistency versus availability. I've seen these trade-off is crucial for most of the system design interviews I've seen, and I think that's where you should focus on, and also latency. So I try to focus on that for each functional requirement. What is the trade-off I should make between availability and consistency, and what's the overall latency requirement for that system? And key numbers will help you assess what's the data you need to handle. So you get number of users, number of files per user, what's the average size file, things like that. That will give you an overview of how much data you're dealing with. So for our system, let's start with functional requirements. Now, what are the functional requirements in our case? I would say file upload is a very important one, file storage is a very important one, and file processing. I think these three functions. So you upload a file, you store it, you process it. Yeah, we're not, you should always ask the interviewer, but we're not addressing authentication and things like that in this tutorial. And for non-functional requirements, we can think of two things. So the trade-off I was talking about between availability and consistency. And in our case, I think that translates to what is more important when I try to upload a file and process it. Is it better that the service is always available, even if sometimes it's not consistent in the sense that I'm getting the latest available file when I check the storage system? So I would assume, for example, in financial trading systems, it's very important to be consistent in financial transactions, because let's say a bank, it's better to have a system that is down, so I cannot transfer money, and than to have a system that is not consistent, in the sense that I send money, but my bank account is not updated on time, so I still have the money on my account, things like that. It's very important to be consistent in that case. Whereas when you're scrolling in your Twitter feed, availability is more important. It's just better to have something to show the user, even if they don't have the latest tweet. So in our case, I will assume that consistency is more important, in the sense that it's better, if it's okay if the service is down sometimes, but the data should be consistent. I should always get, let's say, the latest uploaded file, or any changes. And then in terms of key numbers, in an interview situation, I'd be asking the interviewer, but we can always suggest some assumptions. So in this case, let's say the number of users. Let's say we have 10 users per day, because this is an internal system within a company. It's not consumer directed. And then each user, let's say they upload 10 files a day, and then each file is let's say 1 megabyte, for example. So we have 1 megabyte CSV, and then 10 files per day, and 10 files per user, and 10 users per day. Now, if you have your functional requirements, your non-functional requirements, and ideally these non-functional requirements, they should be at the functional requirement level. So for example, for uploading, consistency is more important, for processing, availability is more important, whatever. But because it's a very simple system, we'll see, most of the times this trade-off is not even relevant. For a bigger system, when you're designing, let's say, Twitter, then you can do things like, okay, so payment processing for accounts will focus on consistency, whereas for the feed will focus on availability. In this case, you'll see that most of the times this trade-off is not even necessary. I forgot to mention, but one non-functional requirement that is important is latency. So we can ask the interviewer, if 1 minute latency is acceptable, and we'll get their confirmation. But let's assume 1 minute latency is required for the whole system. Now, once we have these, it means we've been through the clarifying questions, which should take around 5 minutes. Then we can move on to high-level design. Now, for high-level design, the minimum output that you should get is a bit different. In here, you should obviously have an overall system design. You should have your core entities. So it could be, user file, things like that. In our Twitter example, that would be user, tweet, a thread, things like that. Whereas in here, it will be probably users and files. And in this step, you should address at least the functional requirements. So let's see how we could do this high-level design in our example of a CSV file harmonizer. I think it's a good approach to always start very simple and have a sort of a template that you can use for most of the systems. So in our case, I'm using a sort of a single server setup, which will always be, so you have a user, you link this user with an API server, and then this API server, you link it with the multiple services we'll have. So for now, let's use just one single service to make things easier, and then we'll develop on that. Let's say it's your CSV harmonizer service, and then we can build on top of that. And then this CSV harmonizer service will communicate with a database to store the files, so file storage. And that's it. That gives you a sort of a baseline to start with. Now, how can we tackle these? How can we approach these? And since it's a system design interview focused on an AI engineer role, the goal is obviously to use AI to tackle these. One approach that I thought of is you have a sort of a CSV template. So that's your gold standard format for CSVs. And then you give it to an LLM together with the user CSV, not the whole file, but just the schema, so the column names and the data types. And then you ask an LLM to write Python code that can convert that CSV into the gold standard format, and you run that code, and that's it. I think this is a good solution because it allows you a lot of flexibility in terms of CSV formats. Because one of the things about this system is that it should be robust to many different CSV formats. It's not like you have these 10 formats they use all the time that you just reuse the same code over and over again. Anytime any user could upload a different file format that you should be able to handle. So to use this approach, we should probably split this service into two. A sort of one service that will sort of build the prompt, call the LLM, things like that. The other one that will run the code. So we could call this first service the code generation service, and the second one the file harmonizer service. And then we need to add an LLM here, which will be called by the code generation service. So if we want to check if our first design is good enough for this step, we should check if it answers the functional requirements. So, let's go over our checklist here. We do have an overall system design. We do have some core entities like the user and the file. And we address the functional requirements. So the functional requirements where you can upload through the API server, you can store it, and you can process it in these 2 steps. So we've addressed this functional requirement. We can then try to deep dive. So now we can build on this high-level design during our deep dive. So for the deep dive, I think there are like minimal requirements and then some nice to have stuff. So for the minimal requirements, I think you should have at least addressed your non-functional requirements. And as a nice to have, I think it's good to have API detail and data schema. So you should check with your interviewer if they're expecting these. But I think it's a very good nice to have if you have the time. Now, in terms of non-functional requirements, we got some key numbers. We never did math. And I think this is somewhat common in system design interviews to have this sort of a back of napkin estimation. In this case, it's very simple. It's just you got 10 users a day and 10 files per user per day. So this means every day you have 100 files. Each has 1 megabyte. So in total, you have 100 megabytes per day of storage, which is really not a lot. So, in the end of the year, for example, in 1 year, you should have around 36 gigabytes of data per year, which is really not a lot in terms of storage, and also 100 megabytes per day is also not a lot in terms of throughputing. And that will not, that should not be an issue in terms of our 1 minute latency. Probably one of the bottlenecks will be the LLM calling. The rest should not be a problem. There is one key opportunity, I think, for improvement here, which is caching. We didn't think of that, but it could somewhat reduce latency in some cases and make the whole system more optimized. So for instance here, every time we get a new CSV, we're calling this LLM, but we might end up seeing CSV formats that we've seen before. And in that case, we could obviously cache that information. So in here, we could have a sort of template storage that stores not only the base template that is sent to the LLM, but a sort of key value system that stores the Python code for each template, so that this code generation service will check if we already have this sort of CSV schema here. Then we will get the data from the template storage. If not, then we call the LLM. In this step, it's also important to detail some of the types of technology or storage or whatever that we are using based on the functional and non-functional requirements. So in this case, we are mostly doing, let's say for the file storage, the main one, it could be some sort of blob service like S3. We are just storing CSVs. In here, we're not getting to the details of how these files are used. We are assuming they are not sent back to the user, although it could be the case. We are assuming they're being used by some other external service. And then for the template, we might want something that does some key value storage or some cache thing like Redis, for example. It's also important to note that this service is gonna be running Python code that was generated here. So, if you call the LLM, it got you some code. You can then call the file harmonizer service, which will run that code. it is very likely that sometimes that code will fail. There will be some sort of error. So this service should be able to handle errors by going back to the code generation service, saying, hey, this didn't work. And then you should have some sort of retry mechanism with the LLM to provide it with the error message and say, hey, this didn't work. Can you generate new code to fix this error? And then get this new code and run it. And once it's successful, we then store it on this cache thing. Now, because the focus of this tutorial and the interview is more on the AI part, there should be some mention of which LLM are you using or something like that. I think because we're generating code, some sort of a reasoning model, such as O1 or O3 Mini High, for instance. It's not super complex code, but it's still code, so it's better to use one of these, get some structured output in the response, and then run that code. And for the wrap up, it's a good thing to show like that you're capable of spotting some flaws in the system, some opportunities for improvement, and if you had more time, how would you improve it? I think it's a very simple system. Again, I think it's mostly focused on AI engineers and AI engineering jobs, which require less focus on all of the stuff that surround it, and also because it's a very small system, in-company system used by 10 users, not much data. I think it should not be over-engineered. But some of the opportunities for improvement would be to have maybe access to multiple LLMs if one of them is out. Have some resilience in here with multiple API servers to generate things like that, or even to detail a little bit more with maybe pseudocode how this code generation service would interact with the LLM. But yeah, for the overall system design, I think that's it. I hope this was helpful to you. And yeah, let's keep on building.